Okay. Today we will define resistance per centimeter of a given wire by putting the graph of the potential difference versus current. So what are the apparatus required? Apparatus required are the battery that will provide the EMF to the circuit. Then we have the current meter that will measure the flow of current in the circuit. We have the reostat that will change the flow of the current in the circuit. We have the voltmeter that will measure the potential difference across the wire. And how to find the resistance of the wire? We will take the help of the Ohms law. What does the Ohms law says? Ohms law says that the potential difference across the conductor is directly proportional to the current flowing in the conductor, provided the temperature as well as the other physical conditions are constant. So you can see over here that V is proportional to I and V is equal to Ri, where R is the constant of the proportionality, where R is also said to be the resistance of the conductor. Therefore, V upon I is equal to R. So the resistance of the conductor can be found by taking the different readings of the voltage as well as the current flowing in the conductor. So I will take the seven readings of the current as well as the voltmeter. To find the resistance, let us connect the battery over here. So starting from the positive terminal of the battery, the positive terminal of the battery will go to the positive of an current meter. Positive terminal of the battery will go to the positive terminal of the current meter. Negative terminal of the current meter will go to one end of the wire, like this one. One end of the wire. The other end of the wire will go to the bottom of the rheostat. Will go to the bottom of the, as you can see over here, and from the top of the rheostat will go to the negative terminal of the battery. So like this, we are connecting the circuit, and to measure the potential difference, this a digital voltmeter is connected to across the length of the wire. So this is the circuit connection. In order to find the resistance, we will note down the different ammeter and voltmeter readings. So for different ammeter readings, we will have the different voltmeter readings, where we will take 7 readings of each. So before that, we will have some observations where the least count of an ammeter is 0.2 milliampere, then the zero error of the ammeter is nil. Least count of the voltmeter is 0.1 volt and the zero error of voltmeter is nil. Least count of the meter scale is 0.1 centimeter and the measured length of the wire that we'll take over here is 100 centimeter. So in order to take 7 set of readings, we will take this reostat and we will change this reostat so that the current can increase or decrease in the circuit. Okay, so let us switch on the battery. Now this battery I have taken as 2 volts, so it will provide the EMF of 2 volts. And as you can see over here in the current, we have it is now when the resistance is maximum. When the resistance is maximum, the current showing is of the order of 18 milliampere, somewhere around 18 milliampere. So this is the minimum current at the maximum resistance. So keeping at the 20 milliampere, And also I am keeping this digital voltmeter. So it is a type of the multimeter. It can measure the voltage as well as measure the current digitally. So I am keeping this as a at a 20 volt. Okay, maximum range is about 20 volts. So keeping it the 20 volt resistance. When the current is 20 milliampere, the voltage is 0.6. Now you keep at 30. With the help of the reostat, you keep at 30 milliampere. Note down the corresponding voltage. Keeping at 40, you note down the corresponding voltmeter reading. Keeping at 50 milliampere, again you note down the voltmeter reading. Keeping at 60 milliampere, you again note down the voltmeter reading. Keeping at 70 milliampere, you note down the again voltmeter reading. Keeping at 80, you again note down the voltmeter reading. So like this we got this 7 sets of the ammeter reading as well as the voltmeter reading. Now from this data we can plot the graph between the current as well as the potential difference, and by plotting these points you will get the straight line like this, and the slope of this line will give you 1 upon r, and the reciprocal of 1 upon r will give you the resistance of the wire. So from this graph we get the resistance of the wire, and in order to find the resistance of the wire per centimeter, divide this resistance with respect to the length of the wire. The length of the wire that we have taken is 100 centimeter, so the resistance will be in ohm centimeter inverse. And what is the result that we get is the graph between the potential difference and the current is the straight line, and the resistance of the wire is something around something of ohm centimeter inverse. Thank you. A great day ahead.